Hi, welcome to a demonstration of Manaflow. Today we will demonstrate a typical data science workflow performed by research teams working with statisticians. Let's look at this interface. So as you can see here, it's very similar to a Jupyter style notebook. You can have markdown files where I can say hi. You can preview them, you can copy, you can edit. There's also a drag down where you can choose your tool. It can be Bash, FastAPI, Markdown, Python, Streamlit, or TypeScript. You can also delete these cells. There's also an option to share this link to this thread to other people so that you can collaborate in real time. It's like multiplayer. You can also select your compute type, either E2B or modal, or your LM model. This is 4.0, 4 Turbo, or Cloud 3.5 Sonnet. For now, we use 4.0 and E2B. There's also an option to download this entire thread as a Python notebook. We'll dive into that a little bit later. So now let's start with some data. Okay, so I have this data set here that I want to analyze. So there's two ways to get this on Manaflow. One way is to download it and then upload the file. The other way is to go to Google Sheet and then click on this and then select. The last way is to just fetch it with the link. So I'm going to tell it fetch this CSV file and analyze it for me. So now what it's going to do is going to write some bash code to figure out how to download the CSV file from that link. And then after it's downloading it, it's going to start writing pandas code using Python to read the file and then display the first 15 rows. As you can see here, automatically the code is collapsed. This is to allow the non-technical people in the room to not be too scared or intimidated by the code. As you can see here, we have some recommendations for Manaflow. So actually, I think what would be interesting is performing a clustering analysis to group similar patients together. I think there might be different groups of different patients that have, maybe different therapies, maybe different gene expressions. Let's take a look into that. So it's going to perform a k-means clustering, which is a type of clustering, one of the types, and it's going to figure out and save this cluster data into a new CSV file. Okay, so it's going to use an elbow method to determine the optimal number of clusters, and then we have a cluster data that you can download here. So now that's cool, but actually now I want you to do the cluster. Okay, so do the clusters and then visualize them as a plot. So now I'm going to prompt it to do some plotting and visualizations of this cluster. So as you can see here, there's three groups: cluster 0, cluster 1, and cluster 2. Can you explain this graph to me? So for the non-technical people in the room that don't really understand what's going on in these data sets, you can always just prompt it to tell us what is happening. So you have the first principal component, second principal component. PCA is a way to, okay, this is really cool. Actually, what I want to do is I want to know how does each group or each cluster correlate to survival. So I want to know maybe like the survival times of each of these clusters. So it's going to look at them. So cool. So it seems like 0 has a better survival time than 1 and 2. This is interesting. So now it gives you explanations. Let's see. Clusters, you can find some correlation coefficients. Okay, now I just want to see what are the gene profiles of cluster 0. Yeah, so I want to know maybe which genes are great. Might be hard. So these seem like genes. These are not really relevant. So what we'll probably do is actually let's just make a graph, maybe a heat map comparing genes to survival rates, correlations. So let's just make a correlation heat map. Let's see what happens here. So basically what you're able to do is you can actually edit this code, and you're able to see this code isn't really what we wanted. So let's try this. Cluster genes with high correlation coefficients. try this again. So now it's giving us which ones, so let's plot these. So this is actually kind of hard to see. Let's just extract some of the top correlated genes from each cluster. As you can see here, it does make mistakes sometimes, but it's able to figure out from those mistakes and then rerun it automatically. You can also delete these cells for later on, because then it will help you construct the workflow, so it's less confusing. Cool. Let's plot these correlation coefficients for each of these gene clusters using the matplotlib library. As you can see here, there's a lot of good explanations that are going on with the code. The code is just here for, the evidences. This is not exactly what I wanted. Maybe heat map is good. So let's prompt it to do a heat map. As you can see, it's very flexible. You can just tell it what to do, and eventually it'll give you something that is pretty interesting, and that's something that you want to look into. So as you can see here, this is a graph that I kind of more or less understand what's going on, and this way we can actually break down the data into more non-technical aspects. Okay, cool. So this is a good graph, I think. It shows which ones are target genes you want to look at to up your survival rate. Okay, so let's do a task. Okay, let's email this graph and explanation to my email. So it's going to now email this to my email. So as you can see, it made some errors here, but it eventually picks it up and it's able to send the email. Cool. Now it sent the email with a heat map attachment. So this is a heat map, the explanation, and then here is the graph. Okay, so let's say that I'm in a Slack channel and I want to see where maybe okay, so it looks like I haven't actually set up a connection with Slack, so let's actually do that. So in connections you can select Slack, and then I'm going to approve this, and then I'm going to go back in here, and then now since I'm successfully connected to Slack, I'm going to say list Slack channels again. I want to see which Slack channels I have. Seems like I have these channels. Okay, which one am I looking for? I'm looking for research. Okay, since this is a research task, let's actually rename this to research 2. So now what I want to do is post this attachment, this plot as attachment with a brief summary to Slack. Oh, I forgot to say which Slack channel, but it's going to put it into general. Okay, now if I wanted to make it in research, I'll say post it to research. Okay, so it seems like I have a Slack chat here, and it pretty much posts this into Slack channel. Okay, cool. Now let's actually do the fun part of Manaflow. Let's make this entire thread a task. Make this entire thread a task. And start from the beginning with this Google Sheets link to CSV download. Make sure to include the links, Python snippets, and more instructions in the task. Be as detailed as possible. I'm going to do a little bit of prompt engineering to make sure that's able to understand everything that's going on. So now it's going to make this entire thread into a task. It's labeled analyze Google Sheets data and post results to Slack. Okay, so it's going to do everything that we did earlier today. So it's going to visualize clusters, apply some correlation, extract gene profiles, create a heat map, cluster some genes, plot the correlation coefficients of each gene cluster to visualize the patterns, and then extract the top correlated genes from each cluster. Okay, that's really cool. And then now it's going to plot each of the correlation coefficients from each gene cluster, create a heat map, it's going to do pretty much everything that we did today, and then finally email the explanation to me, and then list Slack channels, and then post it into the research um, tab. Okay, cool. This looks good. So let's say yes. Cool. So now we're going to bring it to here. So as you can see that it's using this link. And since it's using this link, that means any edits to this Google Sheet will actually, it'll just get a new CSV file with new data. So I want to save this. I just undid some changes, and I can press execute here. So now it's going to execute this entire task as like a workflow. You can do this as live data comes in with your data set, regardless of where your data collection is. Just whatever source of truth, you can import it onto here, and then it will look for live changes, and you can either execute it manually, or you can schedule it. You can update the schedule. You can say every day at 8 a.m. I want to update, and then you can press update schedule, and it'll do this next run at 8 a.m. But basically what it's doing is just running through everything that we did in the thread.